Nissan Motor Manufacturing Ltd, or NMUK, is a car manufacturing plant in Washington, Tyne and Wear, England. It is owned and operated by the European division of Japanese car manufacturer Nissan. It has been active since 1986. It was built upon the former RAF Usworth. The plaque in the main reception reads, Nissan Washington opened in 1984. Geography: NMUK is located in Washington boundaries, Tyne and Wear, in northeast England. It's built on the former Usworth Aerodrome. A19 and A1231 Sunderland Highway trunk roads. The factory is adjacent to the UK Nissan Distribution Centre and has a number of on-site suppliers. The landscaped NMUK site incorporates conservation areas, such as ponds, lakes and woodland, and currently has 10 on-site wind turbines, producing up to 10% of the energy required for the plant. The site is located 5 miles from Port of Tyne where international distribution is based. History: in February 1984, Nissan under the leadership of Takashi Ishihara, president of Nissan from 1977 to 1985, and the government signed an agreement to build a car plant in the UK. The following month, a 799-acre greenfield site in Sunderland, Tyne and Wear, was chosen. As an incentive, the land was offered to Nissan at agricultural prices, around £1,800 per acre. The northeast region of England had recently undergone a period of industrial decline, with the closure of most of the shipyards on the Wear and Tyne, and the closure of many coal mines on the once prosperous Durham coalfield. The high unemployment this caused meant Nissan had a large, eager, manufacturing-skilled workforce to draw upon. The site, once the Sunderland airfield, was close to ports on the Wear and Tyne, within easy driving distance of the international Newcastle Airport, and close to major trunk roads such as the A1 and A19. The established company became known as Nissan Motor Manufacturing Ltd, or NMUK. A groundbreaking ceremony took place in July, and work began on the site in November 1984, by building contractors Sir Robert McAlpine. One of Nissan's more controversial demands during the talks was that the plant be single union. This was unprecedented in UK industry. In April 1985, an agreement was reached with the Amalgamated Engineering Union. Critics argue that this means the plant workforce is weakly represented. Nissan argues that as a result of the single union agreement, its workforce is much more flexible than at other plants, and it points to the fact that not a single minute has been lost to industrial disputes at the factory. In December 1985, McAlpine handed over the completed factory building to Nissan for the installation of machinery and factory components, ahead of schedule. Phase 1 of the plant construction was completed in July 1986, consisting of a body, paint and final assembly line. The first Bluebird was produced shortly after and is on display at the Sunderland Museum and Winter Gardens. Official opening of the plant by then Prime Minister Margaret Thatcher and Nissan President Yutaka Kume took place in September 1986. By February 1987, NMUK had become the sole supplier of the Bluebird model to the UK market, and work on Phase 2 of the plant began, with plastics moulding and engine assembly beginning in 1988, and was completed in May 1990. This would prove to be a landmark year for the plant, with the introduction of the P10 Primera, the first model to be wholly built at NMUK, replacing the Bluebird. By 1991, the plant turned its first profit of £18.4 million, and was awarded British manufacturer status by the Society of Motor Manufacturers and Traders. By 1992, the plant began to produce 2 models, with the introduction of the highly successful Micra, which was the first car of a Japanese brand to be voted European Car of the Year. The early 2000s was a period of growth for the plant, with the plant being awarded contracts to build the updated Almira, becoming a 3-model plant, and continuation of the Micra and Primera model changes. A 4th body style for the plant was introduced with the Micra C+E 2006 saw the introduction of the Note model, in place of the Almira, and the introduction of the Qashqai. At this point, NMUK had built a reputation for being the most efficient plant in Europe. By 2008, the falling sales of the Primera led to its demise, with the Qashqai becoming the hero model for the plant, with such a high demand that a night shift was introduced to keep up. The Primera had the distinction of being the first model built at NMUK to be exported to the Japanese market. Nearly 5,000 workers were employed at the plant by this stage. However, 1,200 of them were made redundant in January 2009 as a result of the onset of the recession, which saw demand for new cars slump. Despite a temporary suspension of the third shift due to the automotive industry crisis of 2008, the third shift was reintroduced, and the strong demand for the Qashqai has helped NMUK remain strong throughout the crisis. After the crisis, Nissan announced that the new Juke model would be built starting in July 2010, replacing the Micra, and that NMUK would be the European manufacturing location for the electric vehicle Leaf model beginning in 2011, as well as an on-site lithium-ion battery manufacturing facility. 2013 saw the introduction of the second-generation Note and Qashqai. Models produced at Nissan Motor Manufacturing UK, Nissan Micra, Nissan Leaf, Nissan Qashqai, Nissan Primera, Nissan Note, Nissan Almera, Nissan Bluebird, Nissan Juke, Infiniti Q30. Plant functions. NMUK is split into three logical areas: body assembly, paint and final assembly. Each is further broken down into areas known as shops. Press shop, the first shop in the manufacturing process. The press shop is responsible for pressing the outer and inner body panels of the vehicle. NMUK houses a 5,000-ton press capable of pressing two panels simultaneously, one of only two in use in any Nissan plant. Body shop, linked directly to the press shop. The body shop is a highly automated section of the factory with over 500 robots in operation. Pressed panels are welded together to create complete body shells. Body paint shop, body shells are painted in a semi-clean environment using solvent-based paint. Shells are dipped in chemical tanks to cleanse them of any oils picked up on the panels during their manufacture in body shop. Once bodies have been dipped and cleansed, they are then immersed in an anti-corrosion paint dip called ED. This dip coats the entire body, both inside and outside, and is the first paint coating it will receive. Once the dipped body has been stoved in the ED oven, the body progresses to the sealing booth. In this booth, the body has its interior panel joints, floor, tailgate, hood and door edges sealed with a PVC-based sealant, to prevent water ingress and corrosion as the car is driven in the road. Also within this zone, sound pads are added to the floor and boot to reduce road noise. The next booth it enters is the underbody booth. In this booth, similar to sealing booth, the body's wheel arches are sealed using the same PVC-based sealant. Robots then apply the underseal to the underfloor and wheel arches. Also, robots are used to apply the SGC layer to the sills. This coating is designed for abrasion resistance, that is preventing stone chips, scuffs, etc. From here, the body proceeds into the undercoat oven. The next zone is ED sanding booth, where the body is inspected for any minor imperfections received in the ED coat. The next zone is the surfacer booth, where the body receives its second coat of paint, this being the surfacer coat, then into the surfacer oven. Next is surfacer sanding booth, the same as ED sanding. This zone inspects the body for any imperfections picked up within the surfacer coating. Next comes the top coat booth, where the body receives its final coats of paint, these being top coat and claque coat layers. After being stoved in the top coat oven, the body then enters the touch-up booth, where the body has its final inspection for any imperfections picked up in the top coat process. Once the body leaves here, it then moves on to the PBS above trim and chassis to await the next step in the production process. Over £10 million has been invested into the paint shop, in readiness for the upcoming introduction of Infiniti models Q30 and QX30, making Nissan Sunderland the first plant outside of Japan to produce this luxury brand, alongside its current models. Plastics shop, plastic components such as bumpers are injection molded on site. Plastic paint shop, bumpers molded in the plastics shop are painted in the plastic paint shop, which directly feeds trim and chassis. The shop uses a combination of manual sprayers and robots to coat up to 486 bumper sets per shift. The process in plastic paint is similar to body paint. The parts are washed in a power wash facility before being masked. From here the parts are painted with primer, then base coat. Some colors get 2 coats of base coat at different stations. Then all parts receive a layer of clay coat before being stoked in an oven. Casting shop. Aluminium engine components such as cylinder heads are produced in the state-of-the-art casting plant. Unit shop. 1.2 turbo, 1.2 supercharged, 1.6 and 2.0-liter petrol engines are built on site on the unit assembly line. The cylinder heads and camshafts are machined along the machining line before being shipped to the assembly line. The unit shop contains its own engine testing areas. Diesel engines are no longer produced at NMUK. Axle shop. A second welding facility costing over £5 million is currently being built to ease demand on the axle shop for Qashqai. Trim and chassis. There are 2 parallel assembly lines in NMUK. Line 2 currently handles the Duke and Note. Line 1 handles the Qashqai and Leaf. Painted bodies are stored in a large holding area called PBS, and are released in a specific scheduled sequence. They are brought into trim and chassis on suspended cradles. Each body moves through the assembly line and is fitted with interior and exterior components. At one point in the process, the bodies are married to a sub-assembled engine and subframe. Completed vehicles are sent down a final line, where all aspects of the car, from brakes to waterproofing, are tested. The car is then driven offline to a holding area, ready to be distributed to a dealer. Offices. Although the plant is made up primarily of manufacturing areas, there is also a large office complex, housing supporting functions including personnel, community relations, production control, engineering, finance, purchasing and information systems. Some of these support functions, including purchasing, finance and information systems, are not just responsible for NMUK but for Nissan Europe as well. During a company restructuring exercise in 2003, large parts of the purchasing department were relocated to Cranfield. This angered many in the plant, but widespread industrial action was avoided. In 2005, parts of the finance department were relocated to Budapest in Hungary. In both instances, NMUK adopted a policy of finding new jobs in other departments for those who did not want to relocate. Information technology. NMUK relies heavily on information technology to function. Computer-controlled robots and other machinery, particularly in the body shop, are vital to production. These machines are maintained and controlled by specialist engineering teams. Other functions, such as the complex scheduling of vehicles, parts control and ordering, vehicle tracking, etc., are managed by software written in-house. Most of the software resides on an IBM mainframe computer. This mainframe is not just responsible for NMUK. It controls business functions across the Europe region, including NMUK's sister plant, NMISA, based in Barcelona, Spain. The mainframe is located within the European Data Center, which houses and maintains the mainframe and over 50 servers. Workforce and productivity. NMUK is one of the most productive car plants in Europe, producing more cars per worker than any other factory. There are 4,500 staff directly employed by NMUK, and approximately 500 contracted, indirect staff. Employees at NMUK work a standard 39-hour week. While office staff work on a fixed day shift basis, manufacturing staff work alternating morning and evening shifts. Morning shifts run from 7 a.m. to 3:18 p.m. Evening shifts run from approximately 4:35 p.m. to 12:53 a.m. Shift times can vary depending on requirements. When required, overtime is worked, although it balanced out during the year with planned downtime. A 3-shift system has been introduced at times of high demand, meaning that the factory is active 24 hours a day. This is something that is only introduced if NMUK officials can be sure demand is high enough. Line 1 ran 3-shift production from August 2008 to the start of January 2009 to meet unprecedented demand for the Qashqai. However, due to the credit crunch and falling orders, the third shift was suspended and people released by voluntary redundancy. Staff at NMUK use a number of methods to ensure productivity remains high. Three of the main ones are Kaizen, just-in-time and job rotation. In July 2011, Nissan announced that it would be recruiting a further 200 jobs at the plant to deal with record levels of production. Kaizen is a Japanese word meaning continuous improvement. NMUK encourages all of its workforce to seek out areas in which improvements in their working environment, no matter how small, can be made. For example, a line worker may have to bend down to pick a part out of a box as each vehicle goes past. This could have health and safety implications, as well as wasting time. Kaizen teams would then investigate, and possibly introduce a method in which the box is stored at an optimum height, within easy reach of the line worker. Kaizen teams are based in every department. The emphasis is on small, manageable improvements, although large Kaizen projects have been undertaken, for example platforms that follow the vehicle down the line to prevent workers from having to walk alongside it while working. Just in time, the JIT philosophy, encourages the use of the minimum amount of resources necessary to add value to a product. NMUK uses this management technique throughout the factory and beyond. Synchronous suppliers deliver parts line-side only when they are required, therefore reducing the need to store large supplies of parts at great cost. Job rotation. To keep the workforce flexible, NMUK operates a policy of 1 worker 3 jobs, 3 workers 1 job. In other words, a worker should be competent in at least 3 different jobs, and at least 3 people should be capable of doing each job. This principle ensures that each job can be covered in the case of absence. It also means that jobs can be regularly rotated to prevent a worker from becoming bored in a particular role. Training. In accordance with its Investors in People responsibilities, NMUK has a strong training department and offers a wide range of on- and off-the-job training. The Flexible Learning Center established on site is open to all staff and allows them to take part in over 300 courses. Technical on-the-job training is available to all staff, and most of the courses are given on site by qualified trainers. People development courses are also provided. NMUK spends more per head on staff development than the British industry average. NMUK has a continuous development program whereby staff are given personal and professional objectives every year, and are appraised against the objects. This appraisal is linked to pay increases. This is also an opportunity for staff to identify where further training may be appropriate. References. External links, official website, Grid reference NZ340582.